Welcome. Thank you all for joining this webinar about doing audio measurements without breaking the bank. My name is Clemens Valens. I work for Elektor, and I will be assisting our guest presenter, Alfred Rosenkrenzer. Alfred Rosenkrenzer is a hardware development engineer with over 30 years of experience in the field of analog circuit design and filter development. He is also a regular contributor for Elektor. Alfred Rosenkrenzer put this presentation together, and he knows everything about our subject. So hello, Alfred. How are things in Germany today?
Hello. Yeah, pretty good since I just returned from a relatively long vacation through southern Spain, so everything is fine, except the bank conto.
So you're well relaxed. That's good.
Yes, I am.
Okay, this webinar is being sponsored, and I have a message from the sponsor. This webinar is sponsored by Kurt Electronic. Kurt Electronic is one of the leading manufacturers of testing and measuring instruments for the areas of information technology, telecommunications, and electrical installation. Kurt Electronic stands for quality, user-friendliness, and innovation in measuring and testing technology for over 40 years. For more information, visit www.kurtelectronic.de. This website is also in English. Having that said, we can continue. This webinar is intended for people interested in measuring the key characteristics of audio circuits using free or low-cost audio measurement software and a sound card. We'll share some hardware enhancements to help you improve the quality of your measurements. We will use filters to reduce noise and distortion and to clean up signals. We'll also answer some of the most common questions about audio measurements. At the end of this webinar, you can ask questions, as is usual. You do this by typing them into the Q&A chat box, which is on the right side, bottom right corner of your screen. At least it is in my case. We also have a survey, and I think the question should pop up now. There we have one. Have you used audio measurement software and USB sound cards before? So you can vote now. We'll leave it on for a while. Gives us an. In the meantime, I will say that we also have a giveaway. The giveaway is the Elektor Audio Collection USB stick. You do this on a web form where you have to type in the code word, and the code word is filter. Then this webinar is being recorded and will be available afterwards on the Elektor TV channel for replay. Let's see how we are doing with the. So we have 75%, 72% of our participants have some experience in our domain, so that's good. Like I said, you can join the giveaway by clicking the Enter Now button on the top of your screen. And once again, the code word is filter. Oh, we're getting more experience right now. People are discovering their sound cards as we speak. Okay. Well, let's stop this. And let's go to the presentation then, if I haven't forgotten anything. No. And the presentation is here. The presentation is a pre-recorded video, which we will play without interrupting. There we go. Alfred, you should now mute your microphone, and I will do the same.
Hello, welcome to the Elektor webinar about affordable audio measurement tools. My name is Alfred Rosenkrenzer. I worked 36 years as a hardware design engineer, mainly in the area of analog and digital signal processing for companies like Bosch, Agilent, Fliege and Advantest. They were also working in the area of audio measurement for their IC testers, using instruments from audio precision. Their instruments like the APX 555B are the best money can buy right now. When I retired, I realized that my access to these instruments was limited due to the distance and Corona. So I was looking around for some used equipment, but even for old stuff, long time out of support and repair, you have to pay a lot of money. An affordable solution is to use free or cheap audio measurement software like Audio Tester, REW or ARTA and others, and an internal or external USB sound card. These sound cards are mainly made to record and playback music, but not to be a measurement tool, so they have some limitations. No calibrated input and output levels, DAC output might not be filtered, limited input and output range, generator not clean enough for distortion measurements, digitizer generates distortion by itself. Let's talk about procedures and some small hardware enhancements to improve the quality of the measurement. When you are using a modern function generator, you are used to type in the wanted frequency and the amplitude of the desired signal, and you normally get this at the output. The audio test software lets you define the frequency of the signal, but most of the time it has no control over the gain settings of the attached sound card. Expensive models like my RME Babyface Pro offer a digital control panel beside the hardware control. Simple interfaces just offer a hardware pod, and it's hard to remember the position of it for a certain level. To solve this, I just use my scope to adjust the output level I want. There is one setting inside the software to adjust the digital level going into the DAC in dBFS, which means dB full scale. To avoid distortions, I use -1 dBFS at my RME. Using less does not improve the THD, which means total harmonic distortion, but SNR, signal to noise, gets worse. But this is totally different at a cheap interface I bought for my students. THD was pretty bad at 1 volt peak at the output using -1 dBFS, but much better using -9 dBFS and turning up the level with the pot. The reason is that the power supply for the analog amps is just 4.5 volt, derived from the 5 volt of the USB interface. Using -1 dBFS, the level at the amp behind the DAC is close to 3 volt peak, and there is not much headroom left. The pot to reduce the level is behind. The next picture shows the block diagram. I also check the level of the signal to be measured with my scope. Is the signal too big, like the output of a power amp? It is a good idea to use a resistor divider in front of the digitizer to protect it. With the hardware pod or digital controls of the sound card, you should adjust the level of the ADC. With a clean input signal, you should check the behavior of the ADC to find a sweet spot for distortion measurements. For the RME, it is around -5 dBFS. For the cheap one, it is -10 dBFS. If you look at SNR, a different setting might be the right one, like -2 dBF. Overdriving the ADC input leads to heavy distortion. Generate a sign with your audio interface and have a look at it with your scope. If you see a clean signal, like I see with my RME, the amp behind the deck includes a filter. If it looks like this at the Behringer UMC 202 HD, there is no filter. This is the spectrum measured with the 1 megasample digitizer on an APX 555. I designed a small filter PCB to be installed in the interface. It consists of 2 7-key low-pass filter fourth order. The op-amps are 5-volt types using the internal 4.5-volt supply. If you have another interface or do not like to open it, there is an external filter which fits into an aluminium housing from Hammond. It is powered with ±15 volt and has its own ±12 volt regulators on board. The filter can have gain to get higher output amplitudes. It might be connected at the outputs of the interface. Modern audio op-amps are pretty good in THD and SNR, most of the times better than the loopback measurements of your interface. So no reasonable measurements are possible. To clean up the generator, you can use external low or bandpass filter, described in the article 1 kHz active filter in the last Elektor issue. The next picture shows the frequency responses. Both filter PCBs have the same size and fit on the regulator PCB. Here is the bandpass filter on top of the regulator inside the Hammond box. Normally, the ADCs are worse than the DACs and they also create harmonic distortions. To avoid this, we will measure in 2 steps. First, we measure the signal directly, set the input level of the ADC to the sweet spot and note the level. Second, we insert a notch into the chain like shown in the next picture. The signal will be attenuated to a level where the digitizer and its amps do not add harmonics. Of course, the low or bandpass filter, the test frequency and the notch need to match together. Since the level at the output of the notch is typically small, we can amplify it in the notch or at the input control of the digitizer. The levels of the measured harmonics need to be corrected by the value of the gain. I designed a PCB with a dual Fliege notch and an output amp with 20 dB gain. It is described in Elektor. It includes an input buffer, 2 notches in series and the output amp. It attenuates the test signal by about 70 dB. 1 notch needs 2 op amps. Again, it has the same form factor like the low or bandpass filter and fits on top of the voltage regulator PCB, all together in a Hammond box. There are other structures for a notch filter like the double T or the variable state. The variable state filter has some advantages over the Fliege filter, but it needs 4 op amps. The mentioned filters have a fixed frequency, most of the time 1 kHz. If you like to measure at different frequencies, you need another set of low or bandpass and notch filter. Inside professional equipment, they use adjustable variable state filter. The notch frequency is set with DACs and switched capacitors by the controller, which needs software and calibration. Let's talk about ground loops. This is a severe problem at audio measurements. They pick up magnetic fields from transformers and switched power supplies, and you see your line frequency and multiples or the switching frequency in the measured spectrum. Therefore, the cabling in professional audio installations are differential using XLR connectors. Consumer stuff uses single-ended signals using RCA. One easy way to reduce the effect of ground loops is to tie the cables close together to reduce the open area. The second is to set up the measurement as far as possible away from the sources, e.g. big transformers, etc. To break the loop, you can use differential in or outputs and differential to single-ended amps without a ground connections. Some time ago, special audio transformers were used, but they also generate harmonics. A cheap interface is the ground of the USB connection is often connected to the signal ground. An USB isolator can be used with a separate power supply for the audio interface.
So that was the presentation from Alfred. Thank you very much, Alfred. That was very interesting. Before we continue, we have a survey question, a second survey question. Let me pop up now. There it is. So which one of these are subjects that were treated in the presentation? Which one have you experienced with? Okay, uncalibrated inputs and outputs seems to be the winner of this. With noise shaping and cleaning the output is running a tight race. Interesting. Okay, well, let's stop for this now. And go back to the Q&A. So we are now in Q&A mode, and we will now try to answer questions that you may have. As I said before, type them in the Q&A chat box, bottom right corner of your screen, and then we will try to, especially Alfred, of course, will try to answer them if there are questions, of course.
Okay.
Well, this is a classic. Indeed, you will be able to watch the recording afterwards. We always record the webinars. This one is for the giveaway, the link, using the code word filter. Then we have a lot of people complaining about the left channel. Is there any document about this to be consulted after the webinar? Well, there is no written document. There is the recording of this webinar, of course. And if you want, the articles presented in this video are Elektor articles, so you can read them back in if you have your Elektor magazine. They're also available from our website, of course. You can download PDFs. Okay, here we have a question. I didn't catch what the UMC 202 HD did. Can you please explain?
Yes, this UMC 202 HD is from the company Behringer, which is famous for, let's say, affordable music, electronic stuff. Anything you might need, like mixing stations, amplifiers, and so on. And they also do a couple of USB audio interface. And this is one which is relatively cheap, so around 85 euro last time when I checked on a company, a distributor of such things. And it's much, much cheaper than the RME Babyface Pro I bought before, which is a little bit better, but it cost me 720 euro. So I was looking for some, let's say, affordable interfaces for the filter class I'm doing on a university for the students, that they can do their own measurements. And of course, you know, universities are always a little bit short on money. So I was looking on a affordable one, and this one I found is pretty good to start measurements in the audio range with very little money.
But I think the problem was that its output was not filtered.
Yes. So I was surprised when I had a look at the output directly with the scope, and I found there is a blog on doityourselfaudio.com about this Behringer, and you can find a schematic there for the analog part, and you can see that there is no filter outside the DAC, and inside the DAC is the commonly used noise shaping, which moves out stuff out of the, let's say, the 20 kilohertz range you can hear, but you can still see it. So it does not look very good. So I designed a filter to get rid of everything above 21 kilohertz.
Okay. And then we have a question: how comparable is a sound card such as a Focusrite 2i2 compared with an Audio Precision?
I have no idea. I heard this name, but there are so many out. I cannot buy everything, and just buying something and ship it back a week later, that's normally not done by me. So I don't know.
Okay.
I tested some other ones which were described in this article about my RME and audio tester software, and I found that they were not very good. So that was the reason to buy the RME when I got a tip from somebody else that this one should look pretty good, and it really does. But as said again before, it's pretty expensive.
Okay. Then a question: if I want to measure loudspeaker frequency response, I need a good microphone. Can you give tips for not so expensive but usable microphones for this?
Okay. Again, from the company Behringer, there is one for below 100 euro. I do not remember the one, the real price. I can just show you. Hold on. So, can you see it here? It's called ECM 8000. And for my stuff, it's good enough. But of course, there are better ones outside, but you have to spend more money.
Yes, and this webinar is about not spending money if possible. So,
Yes.
So how do you make measurements at audio amplifier outputs?
Yeah. One thing is, of course, you have to use a resistor divider at the output that you will not destroy the input of the digitizer. Just a short story. One pair of my students, they did exactly that without thinking of the big amplitudes at the output. And these guys destroyed 3 of the interfaces before they noticed that there is something going wrong. So I should fire them. Anyway, so at the end, you need a resistor divider with good, maybe leaded resistors and metal film resistors. And many times I saw problems with ground loops and things like that. So I'm using differential output of my RME and then a special differential to single-ended amplifier, which has no ground connection. So I break the ground loop, and this gives much better results in the output spectrum and, of course, the frequency response.
Okay. Then using an oscilloscope with FFT spectrum analyzer functions, how much vertical resolution would you need?
The 8-bit is not enough, even the 10-bit is not enough. It's good enough for, let's say, high-speed signals to measure THD in the range of 40, maybe 50 dB. But in audio, an amplifier with 40 dB is just defect. So forget about that, unfortunately.
Okay, so you have to invest in an expensive one. Again, on sound cards, I have great experience with a Steinberg UR44 and Focusrite 2i2. And how do you compare the quality to the RME Babyface Pro?
Okay, I tried a Steinberg, but another one. I think it was called UR222 and 22.3, which are owned by former colleagues of mine. And I found that their spectrum does not look very good. I have no idea about the UR44, and I have no idea about the Focusrite. But the RME is much better than the UR22.
Okay,
so if you look at the article in the RME about the RME interface, there are spectrums there, and if you like, just give me a mail to my mail address, and I can send you some pictures of spectrums.
Okay, if you want to send an email to Alfred Rosenkranz, send it to Elektor, then we will forward it to Alfred. And just what you said about the UR22, I have a Steinberg UR22 right next to me, so if the sound quality of my microphone is bad, then we know why.
Maybe that's a different thing. What you hear and what you measure.
Okay. More sound cards. Interfaces. Did you compare the UMC 202 HD to the Quantasylum products?
I heard about the Quantasylum products like the QA403 and upcoming 404, but so far I had no chance to really compare them. I just saw their measurements on their blogs, but unfortunately I couldn't get the hands on it. Maybe Elektor will help me to get one in my fingers.
Yeah,
they are in the range of $500, I think. And yeah.
Yeah, it's more expensive. So here a more practical question: how to measure resonance of a room using DIY devices?
I'm not an expert in doing sound measurements in a room, so sorry, no idea.
Okay, we go back to loudspeaker frequency response. Why would you need a microphone to test it?
Okay. How should I measure the sound without a microphone? I'm lost.
I think he just hooks up an oscilloscope to the loudspeaker wires.
Yeah, but then you measure the amplifier, but not the speaker itself.
Yeah, yeah. So that's why you need a microphone. You have to measure what comes out of the microphone. You could use a laser if you like, but that's a kind of microphone then.
Yeah, and burn some holes into your speaker.
Do you have any experience with isolating via USB isolator?
Yes, I do. That's also a good idea to get rid of any ground connection to your PC and to put in a clean power supply from the outside into your USB interface. I used things you can get on eBay for, I don't know, $30 or 30 euros, but they are only the USB 1.1, the 12 megabit stream, not the USB 2.2. We have in the company, we have some USB 2.2 and 3.0, which are doing the job, just breaking the ground connection to your PC.
This keeps coming back, the UMC 202.
What about the use of analog signal generator and use? What about the use of analog signal generator? Yes, you can do that, of course. But then you need an extra instrument or a analog signal generator, which are also described on doityourselfaudio.com. You can buy there a PC board for a handful of dollars. So, but then you're stuck to one frequency typically. Normally they are not adjustable. So typically you can get it for 1 kilohertz. If you need 2 kilohertz or 3, you need a different PCB and change it, the caps and the resistors.
Here we have a suggestion. We use an ECM 3000. Do you know it?
Mm-hmm. Okay, thanks.
Yeah. Then we go to the Red Pitaya. 14-bit ADC DAC DAC. Would that be good?
I have no idea about that. Do you have any?
Red Pitaya?
Excuse
Red
me?
Pitaya is a kind of, it's an FPGA oscilloscope, sort of.
Uh-huh. So no idea, not used so far.
So it's very fast, but it's only 14-bit.
Mm-hmm. Yeah, so even the interface chip inside the bearing is using 24 bits, and also the software is using 24-bit. So even though the 24 are not real, maybe only 18 or 19 or 20, but I think it's better than a 14-bit. It's a different instrument for a different usage, I think.
Exactly.
But to be honest, I never tried it to do audio measurements.
then can you suggest a microphone for ultrasound up to 80 kilohertz?
No, sorry.
No, we published a few years ago a bed receiver, and that had a ultrasound microphone on it. But you have to look it up in the Elektor archive. And I don't know if it's a good one. It was just one that we could buy.
I bought this, and it works as the bed detector very well. So you can see and hear or see on an instrument what is flying around in the evening around your house.
Yeah, it's a fun tool. Let me see. Do you have experience with sigma delta noise shaping over the 20 kilohertz up to 192 kilohertz range?
No, I just know that they are using it in the decks, and I remember that I read how it works, but that's it. So I just take it as it is.
Okay. Can you recommend any simple DIY or board amplifier for measuring audio from speakers or passive crossovers?
Well, I use, what is it? It's an old Cyrus amp, which is relatively good, but I think you can use any good power amp from Sony or any company like that. So also the Elektor stuff, even though I published an amplifier some years ago, which was pretty good. So I have nothing special.
Okay, I can combine this in one amplifier, a DIY, and you have to buy it because it's a kit. You could use the Elektor Fortissimo. So according to your experience, what software do you suggest as the best spectrum analyzer?
I'm using Audio Tester, which you can try for, I think, 4 weeks for free. As long as you do not get a license, it switches off after 10 minutes usage. The license is €39, I think, and it works pretty stable and good. And there is also something else I also tried, which is RWE, room equalization, something like that, which is free and works also very well. There is also Arta I used before, but I'm not aware that there is something else outside, but which does not mean there is nothing else outside. So it's only, so I also tried the RWE a few times, but always came back to Audio Tester. The point is, even though it's almost free, it's relatively complicated, and you need some experience, and this takes time. And I didn't want to spend this time again on the RWE, since I did not see anything which leads me to use this one. So these are the one I would recommend.
Okay. I see someone complaining about my audio, that I should buy a new mic, but I have a super duper Sennheiser microphone. So for me, it always works fine. I cannot hear how it sounds on the other end at your side. Is my audio really distorted?
No, I hear you pretty clear. So
that must be a problem on the participant side.
Yeah, so sound seems to be good on some places.
Yes, other people say that it's okay. I don't see any more questions. Oh, here's one. Have you tried Blue Cat Audio Frecanalist?
No, never heard about it.
So maybe try it then. This is a good one.
No, sorry, I misspelled the REW, so Room Equalization Wizard. So I'm sorry.
REW. RWE is electricity company. Okay. Can you recommend any books on audio test and measurements?
There are quite some books from, I think, Mr. Douglas Self, right?
Mhm.
So at least on designing amplifiers and things like that. On audio measurements, there are also tutorials from Audio Precision, which of course they use their instruments, but you can do the same on cheaper instruments. But it's the way how you measure, it's described pretty good. You just have to exchange the audio precision to the interface you're using.
Okay, here's a software question. Do you have
No.
any insight and experience with WDM versus ASIO?
No,
No.
sorry.
A tip from a reader. Bob Cordell has a chapter in his Audio Power Amp Design book.
Mm-hmm.
This is Douglas Self, I think, Small Signal Audio Design. Do you have experience with audio test software under Linux?
No, I'm not a Linux guy.
Is Audacity of any use for this kind of measurements?
Excuse me, say it again.
Audacity, you know, Audacity software?
I never heard about it, sorry.
Oh, it's a very popular one. It is for recording audio, but you can apply all sorts of effects on it and do all sorts of measurements in it. And it runs on Linux and on Windows and on Mac probably also.
So somebody is asking about a handheld spectrum analyzer. Yes, there is a company in Liechtenstein, NT Instruments. They are doing handheld audio generators and also spectrum analyzers, but with a small LCD interface. So, and they are around 500 euros or so. So it's relatively expensive. It works fine. We had them in the company, or we still have them. Unfortunately, I'm not in the company anymore to use it. But you have to spend around 500.
Someone mentions Audacity, the software I just mentioned.
Yeah, I heard about that, but also not used.
And any ideas about very low audio frequency detection measurements, DC to 30 hertz? Well, DC is no longer audio, I think.
Yeah, not really, of course. I'm looking for line frequencies and to get rid of them. But below 10 hertz, I'm not really measuring. So no infra, was heißt Schall auf Englisch? Sound.
ELF, but that's maybe even lower.
Infrasonic now. Yeah, thanks for that.
Can you say the name again of that handheld spectrum analyzer?
Yeah, the company is called NTI, and it's a split of Neutrik, which make these famous XLR connectors and so on. And I think the web address is just ntinstruments.com.
Well, you can Google that right away. NT Instruments. It would be this one. New technology music, they make musical instruments.
Yeah, so somebody just typed the internet address.
Oh, here it is. Yeah. So it's NTI Audio and not NT Instruments.
Okay, sorry.
Unless you want to buy a violin, because they sell violins and other musical instruments. This one. So it's not this one. Ari, not this one. For interfacing with the DUT, I have some experience with Arta 2.
Mm-hmm.
Do you know any other test equipment between DUT and audio interface?
For interfacing with the DUT. I have some experience with the Arta 2. Is Arta 2 the software or something else?
I don't know. I will.
So sorry.
It's in Greek.
So go on, please.
Yeah, well, we are leaving here. We have Arta 2 is.
Mm-hmm.
Okay.
Sorry.
I know Lavain, but I don't know.
I heard about him, but I have no idea what he is using.
Okay, well, I think we have come to an end. We don't really have any questions anymore. So let's put on the last slide here. This one. So that's it for now. I hope you found it useful and interesting. As I said at the beginning, this webinar will be available in a few days on the Elektor TV channel on YouTube. Don't forget the giveaway using the code word filter. It will be valid for a few, for I don't know how long, but for a while. So you can still participate if you didn't do so already. Alfred Rosenkranzer, thank you very much for doing this webinar with me, and I hope you found it. It went as you hoped for, and thank you all for attending.
Yeah, and if somebody else has any further questions later on, just contact Elektor and they will forward the emails. So I'm in short before, or I stopped working for some time. So I'm always answering any questions.
Okay, if you do so, please put in the subject of your email that is webinar, that's question related to the webinar, otherwise we will get lost. So once again, thank you very much, Alfred.
You're welcome.
Thank you all for watching, and thank you, and hope to see you next time. Goodbye.
Bye-bye.